The cosmos is vast, stretching beyond our wildest imaginations. Billions and billions of stars fill our galaxy, each one a potential sun to its own system of planets. And there are billions of galaxies out there, each teeming with countless stars and possibly even more planets. It makes you wonder, are we alone in this immensity? Could there be other beings looking up at their skies asking the same question? Or is there life elsewhere, perhaps on one of the many exoplanets we've discovered? The possibility of life beyond Earth has fascinated us for centuries, inspiring countless myths, stories, and scientific inquiries. From ancient philosophers to modern scientists, we have always looked up at the stars and pondered this profound question: what lies beyond our world? Now, more than ever, we are equipped with the tools and knowledge to search for an answer. Advanced telescopes and space missions are pushing the boundaries of our understanding. Our journey begins by understanding the conditions necessary for life as we know it. We need liquid water, a source of energy, and a stable environment. These are the building blocks of life. These are the basic ingredients for life to emerge and flourish, creating the rich biodiversity we see on Earth. But what if life elsewhere doesn't follow our rules? What if it exists in forms and environments we can't even begin to comprehend? What if it thrives in ways we can't even imagine? The possibilities are as endless as the universe itself. The universe is full of surprises, constantly challenging our understanding and expectations. Our search for life must remain open to all possibilities, embracing the unknown and the unexpected as we continue to explore the cosmos. Imagine a star, blazing with light and heat. This star is the heart of its own solar system, a beacon in the vastness of space. Circling this star are planets, some close, some far away. Each one follows its own unique path, influenced by the star's gravity. In a special region around the star, conditions are just right for liquid water to exist on a planet's surface. This region is neither too hot nor too cold, not too hot, not too cold. This delicate balance is crucial for the possibility of life as we know it. This is the habitable zone, sometimes called the Goldilocks zone. It's the sweet spot where life has the best chance to thrive. Planets in this zone are prime candidates for hosting life. They have the right conditions to support liquid water, a key ingredient for life. They have the potential for oceans, lakes, and rivers where life could emerge and evolve. These water bodies could be cradles of life, nurturing it over eons. Earth, our own blue planet, resides comfortably within our sun's habitable zone. It's a prime example of a world where life has flourished. But the habitable zone is not a guarantee of life. Many factors must align for life to take hold. A planet must have other essential ingredients, like a protective atmosphere and a stable climate. These elements work together to create a hospitable environment. And even then, life may not arise, or it may take forms very different from what we know. Life's potential diversity is vast and unpredictable. Still, the concept of the habitable zone gives us a starting point in our search for life beyond Earth. It guides our exploration and fuels our curiosity. It helps us narrow down the billions of stars and planets to those most likely to harbor living worlds. The search for life continues, driven by the hope of finding a place where life could thrive. Here on Earth, life exists in the most extreme environments imaginable. These environments are so harsh that they seem uninhabitable, yet life persists. From scorching deserts to icy polar regions, these places test the limits of survival. From deep ocean vents to acidic hot springs, life finds a way. These environments are not just extreme, they are often deadly. We call these hardy creatures extremophiles. They are microorganisms that have adapted to survive where most life forms would perish. Some extremophiles thrive in boiling water, enduring temperatures that would cook other organisms alive, while others survive in sub-zero temperatures, where the cold would freeze most life forms solid. Some can withstand intense radiation, levels that would be lethal to humans and most other life forms, while others flourish in highly acidic or alkaline conditions, environments that would corrode or dissolve most organisms. These organisms challenge our understanding of what life needs to survive. They push the boundaries of biology and chemistry. Extremophiles teach us that life is incredibly adaptable. Their unique survival strategies offer insights into the resilience of life. They expand our view of what's possible beyond Earth. If life can adapt to such extremes here, it might do so elsewhere. If life can exist in the harshest environments on our planet, it might also exist in the seemingly inhospitable conditions of other worlds. This opens up exciting possibilities for astrobiology, perhaps on a planet with a toxic atmosphere or a moon with hidden oceans beneath its surface. Life has found a foothold. These environments could harbor life forms that are just as resilient as extremophiles. Extremophiles provide a glimpse into the remarkable resilience of life and fuel our hope of finding it elsewhere in the cosmos. Their existence inspires us to look beyond our planet and imagine the possibilities of life in the universe. For centuries, we could only wonder about planets orbiting other stars. Now, thanks to powerful telescopes and ingenious techniques, we can actually detect these distant worlds. We call them exoplanets. The discovery of exoplanets has revolutionized our understanding of the universe. We now know that planets are not rare occurrences but rather incredibly common. In fact, there are likely more planets than stars in our galaxy. Among the thousands of exoplanets discovered, some are particularly intriguing. There are super-Earths, larger and more massive than our planet, and mini-Neptunes, smaller than Neptune but still much larger than Earth. Some exoplanets orbit their stars in the habitable zone, making them potentially suitable for life. The search for life on exoplanets is still in its early stages, but with each new discovery, we learn more about the diversity of planets and the possibility of finding another world where life may have taken hold.